actually kind of wonky because of our book. We go back into topic 10 and work on a few pages, but then we shift over and we move into topic 13. So those of you that came to campus and completed the math benchmark, this piece of paper probably looks very familiar. It was included at the beginning of your benchmark assessment. Maybe you guys have seen this before, but right here you can see that it is a reference sheet and it includes customary conversions, metric conversions, and then if we scroll down, time conversions and formulas. So these should look familiar. These are the formulas for area and perimeter. And some of these probably do look familiar, as in 1 foot is equivalent to 12 inches. A lot of you probably already know that. Maybe you know that 1 gallon is equal to 4 quarts. So these are the measurement conversions that we are going to be spending time on over the next probably 2 weeks. We are going to begin right here with time conversions. So let me kind of zoom in here. And we're talking about these time conversions. So right here, just this section of the reference sheet. And many of these you guys already are probably very familiar with, as in 1 minute is equal to 60 seconds. There are 60 minutes in 1 hour. 1 day has 24 hours. And in 1 year, we have 365 days. This is probably the only one right here that maybe some people know and maybe others do not, but that we have 52 weeks in 1 year. There's one conversion that's not recorded on here, and that is that in 1 week, we have how many days? That's right, 7. So I just wanted to introduce this reference sheet because we will be using this each day. We will refer to this and look at it. And then with some of these conversions, I'll be writing these down as we go through our videos. So follow along in part 2 of this video, where now we go into the book and take a look at some time conversion questions. All right, boys and girls. So again, you watched in part 1 of this video, but right now we're following along on lesson 10.4. So this time lesson does go back to topic 10. I know that's kind of confusing, but we are on pages 397 and 398 for this video. So please make sure you're following along, and let's get started. So let's read this problem together. The Big Sur International Marathon is run on the California coast each spring. Sean's mother was the women's overall winner. So we've got Sean's mother was the women's overall winner. And the reason I highlighted that is that I looked down here at this chart, I glanced at it, and I saw that there's overall, and then I see there's the men's category and the women's category. So I guess Sean's mother placed right here. How much faster was Sean's mother than the women's winner in the ages 65 to 69 group? How much faster means I am going to subtract Sean's mother than the women's winner in this group. So we want to find out how much faster was she here than these people. Tell how you decided, solve this problem any way you choose. All right. So just like a subtraction problem, even though we're using time conversions and units of time, I can still set this up like a subtraction problem. Now I know that we're talking about a race, so this is a little confusing. The higher numbers indicate a slower time, right? Meaning here's the start, here's the finish. So at 2 hours and 50 minutes, that's when Sean's mother finished. 3 hours and 58 minutes, these guys were probably back here somewhere. And by the time they got up to the finish line, it was even longer, right? So this time right down here, the 3 hours and 58 minutes is actually longer. So I'm going to put that up top. 3 hours, 58 minutes. That's our larger number. And then we're going to take away the time that Sean's mother ran. So 2 hours, 50 minutes. Now I can go ahead and do my subtraction. First, I'm going to find the difference in the minutes. So 58, take away 50 would leave me with 8 minutes remaining. And then if I subtract the hours, 3 minus 2, that is 1. It's only one, so I'm not going to say 1 hours, but 1 hour and 8 minutes. So that is the difference between Sean's mother's time, the overall winner, and the difference between the ages 65 to 69 in the women's category. 1 hour and 8 minutes. Let's look now at the problem down here at the bottom where it says look back. The men's winner in the ages 70 to 74 group took 4 1/3 hours. Before we even begin, let's think about that for a minute. 4 1/3 hours. Well, let's think of our hour because it's the 1/3 part that's throwing me off. Let's say this is our whole or our 1 hour. Well, we're dividing it into 3 equal parts. So I want you to think, you know that 1 hour is equal to 60 minutes, correct? So what number would you have to add equally 3 times to equal 60? Think for just a moment. Great, that would be 20. 20, 40, 60. So that's just something that we need to understand, guys, that if we're given 4 1/3 hours, that 1/3 refers to just one of these sections, so 20 minutes, right? 4 hours and 20 minutes. Now let's look at the second part of this problem. John's grandfather, who is only 68, took 3 2/3 hours. How can you find the difference in these times? Well, 2/3 would be 3 2/3 hours would mean breaking apart our hours still into 3 equal parts because that's our denominator. And we now know 20, 40, 60, but 2/3 would be how many minutes? 40. So while this was 4 hours and 20 minutes, this is going to be 3 hours and 40 minutes. So there's 2 different ways we can solve this problem. Let's take a look. We want to find the difference in these times. So we could do 4 1/3, and we could take away 3 2/3. Well, right away, just reviewing what we know about subtracting mixed numbers, I know that I cannot take 2 away from 1. So I need to borrow and regroup. So this is going to change to 3 hours. And then if I add the group of 3, so plus 3/3, I now have 3 4/3 hours. And I'm going to subtract the 3 2/3. Well, the 3's cancel out, obviously. And now let's subtract the fractions. 4 minus 2 leaves me with 2/3 hours. Now, let's take a look. You could respond and write 2/3 hours. Or maybe you want to take it a step further. Knowing what you know about dividing an hour into 3 equal parts, you might want to say, if there's 2 of them, we said that is 40 minutes. So there's 40 minutes difference. Now, is it still acceptable, though, to answer and say 2/3 hours? Yes. Let's move right along. Let's take a look at page 398. So we're right up here at the top. So sometimes we have to add when we're solving using time problems. Sometimes we have to subtract. In this case, we might even multiply. Crystal is training for a race. She trains every day for 8 days. So every day for 8 days, that must be important. How many hours does Crystal train? Now let's look. Here's what she trains per day. She trains 3/4 of an hour. Now, I also like to just pause before I get started, and I like to think to myself, okay, 3/4 of an hour. What would that indicate? How much time is she spending? Right. Well, I know that there's 60 minutes. This one was a little bit trickier, wasn't it? We have to think, what number could we add evenly 4 times? Well, this is how I solved. I know that half of the hour would be 30, and I know that 15 plus 15 is 30. So then if I have another 30, then I would have 60. So we know that breaking apart your hour into 4 equal parts means 15 minutes for each part. So just keeping that in mind, let's look at this question. How many hours does Crystal train? Well, what they've done down here is they've taken the 8 days, so 8, and multiplied by 3/4. Now, this kind of goes back to what we learned about multiplying, right? You stick the whole number over 1 and multiply by the fraction 3/4. And I know that 8 times 3 would give me 24, and 4 times 1 would be 4. So 24/4. Well, what do I do with that? Well, I'm going to go ahead and divide. How many times will 4 go into 24 without going over? That would be a total of 6. So Crystal trains for 6 hours. Let's turn the page. I don't want to quite go over this part yet, so I'm going to skip this part for right now. And let's jump over to right here. We have 2 more that we want to go through. So now we are adding time. I'm actually going to get a separate sheet of notebook paper to do this problem with you guys to walk you through. They want you to find 2 hours plus 32, or 2 hours and 32 minutes plus 3 hours and 40. So on a separate sheet of paper, I'm going to set this up, 2 hours, 32 minutes. Sometimes you might see minutes abbreviated like this, and then 3, and you could see hours abbreviated this way, 40 minutes. Okay, so just like when we add normally, we start with place values. Well, this time we're starting with this unit of time right here, starting with minutes. And we're going to add, and we may have to regroup. 2 plus 0 is 2, and 3 plus 4 is 7. Well, right away, my brain is telling me, uh-oh, I know that there's only 60 minutes in 1 hour. So what I can do is take 60 away from here, so minus 60, and that would leave me with how many? You can see what they did. 12. That's correct. Now, when I regroup that hour, obviously I'm going to have to add that up here. So take away this, regrouping it up here, and now I can add my hours. 3 plus 2 is 5, plus 1 more is 6. So 6 hours and 12 minutes. Let's try one that we're subtracting. So let's go over here and get a clean piece of paper. So they want us to find 5 hours and 8 minutes, subtract 2 hours and 32 minutes. Now, some of you might be saying, well, why don't you just switch this? Why don't you just put the 2 hours and 32 minutes on top? Because you still have to know that 2 hours is less than 5 hours. So 5 hours is the larger amount. It must go on top, even though we can't take 32 away from 8. So what are we going to do? We're going to borrow an hour here. So now we're left with 4 hours. And we're going to add the 60 minutes over here. So plus 60. Well, 60 and 8, that would give us a new total of 68 minutes. Now we can subtract. 8 minus 2 leaves us with 6. And 6 minus 3 is equal to 3. So we have 36 minutes, and 4 minus 2 is 2 hours, 36 minutes. Okay. So today, you are going to try a few of these out. I want you to try problem number 2 and 3, 4 and 5. We're going to skip 6 and 7. Those really are not important for us to know how to do. They're just kind of walking you through what you're doing when you're multiplying fractions. So 2 through 5, and then we're going to go to the back, and we're going to do problems 8, 9, 10, and 11. And then we'll meet at 2 o'clock to go over those problems.